Continuously 2 hours on
It's mom. Yeah.
Yeah.
I don't know how your classmates felt. I mean, your other section students, how they felt. So right now we have completed for both the sections, we have completed 2 units. So today we'll start with a fresh unit, that is unit 3. So unit 3 is going to deal with network layer. So you must be knowing, as per the OSI reference model, already we have studied about this OSI reference model and the TCP IP model. So by this time you must be knowing about the functionality of this network layer, isn't it? Yes. Yes, ma'am. Yes. If you have any doubt in unit 1 and 2, you very well ask. So we have completed unit 2 units. Unit 1, we have just looked into the architect, the 7-layer model and the 2 different models for your network layers. And then we also discussed the physical layer. Followed by that, we discussed the data link layer in unit 2. And today in unit 3, we're going to start with the network layer. So what is this network layer all about? What is the main responsibility of this network layer? Okay, what is the main responsibility of just I will give you introduction about this network layer. So, this uh, physical layer is responsible for carrying your data, that is raw data, which could be, I could say, in form of signals. It will be converted into the form suitable for transmission through the medium. Whereas data link layer will add some more extra things to it. It means in order to use the medium, who should actually, what is the discipline that should be followed in the medium, how the data has to be, how to identify the error, whether there is any error, how to detect as well as to correct, all that is taken care by the data link layer. Now, this network layer, as you know, is going to be the layer soon after the data link layer, and is going to get the service from the data link layer, and is going to provide service to the layer above it, that is the transport layer. It means it is this layer which is responsible for efficiently carrying the packet. So we call it as raw data as bits in that physical layer, and the combination of bits with some add-ons, you call it as a frame in the data link layer, whereas you call the things as, that is the data, what is going to be transmitted is said to be called by the name packet in case of network layer. So it is this network layer which is responsible for interconnecting your different network. So you know what is meant by a network? What is network? So yeah, connecting link among so more than two or more than one is there. Then when how do we connect ourselves? In our WhatsApp also we have some 60, 70 of your people together. We are all together, and that is a network, isn't it? So it is this network layer which is responsible for efficiently, carrying the packet from the source to the destination point. So the preparatory work is done in the physical and the data link layer, whereas the effective transfer of packets from the source to the corresponding destination is taken care by the data link layer. So it gets the service from the layer below it, and it provides service to the layer above it. So as such, what are the different functionality of this network layer? So the very and the most important function that is provided by the network layer is internetworking. So you may be having a LAN, sometimes you may be having a wireless LAN, and a combination of LAN is put together is called as a wide area network, and it goes on. All these are going to get connected together. How to efficiently connect them together so as to have interconnection. So your internet is the internet, different networks are connected, and that is why you call it as the internet. So how to efficiently connect the different networks, that is taken care by the network layer. Then what are the other functions that is provided by this network layer? So the very first function is internetworking. Okay, so internetworking is the very function provided by the network layer. The next function is that is provided by the network layer is addressing. You have heard of the name IP address? So in this network layer, each and every device in the network is provided by an unique address. Just a second. So each and every, I can say each and every device in the network layer is provided with an unique address, which is very unique to it. Only then it is possible to identify the source as well as in the destination, and to effectively, the layer can able to transfer the packet using the protocol. Okay, so like how we ourselves are identified, how do you identify, even though you some may, I think in A section, there was 2 students with the same name with the same initial, but still, how do we differentiate them? We differentiate each and every one of you by your register number. So this register number is unique. There's no repetition. Likewise, each and every device is provided with an address, and that is taken care by the network layer. Then the next important function that is provided by the network layer is the third function. Can you guess what? Routing. So you throughout you can able to see the word routing everywhere in the syllabus. So this is the third function that is provided, or that is taken care by the network layer. What is this routing? Just a guess. Can you give an answer? What is this routing? So just you are trying to go from your classroom to the mess hall. So how many routes you have? You can go straight to the admin block. You can go straight to the main road, or you can take the central library side. You can go through chemical department. You can go through like that. You have several routes. So not every one of us will be choosing the same route. It depends on our own convenience, isn't it? It may be some may want the shortest route, some may want to just walk for a longer distance, some may be feeling to walk under shade. Like that, it depends on the cost. So that is called as the cost function, which is more important for me. That will be taken care, and based on that, the route from source to destination will be decided. Okay, so that is one other important function that is provided, or that is taken care by the network layer. Then what else? Packetization. Packetization as well as fragmentation. Packet, P-A-C-K-E-T, packetization. So, and the fragmentation. Sometimes you may want to combine your data into one single packet. Some may, yes, ma.
RIP also used for routing, ma'am.
Pardon, ma?
RIP, RIP.
Where is RIP?
RIP also using for routing, ma'am.
What is that, ma? RIP?
Routing information protocol.
Yeah.
Yeah,
Where it is? Where it is, ma?
I am asking, ma'am.
What is that? What is that? Routing information protocol.
Routing information protocol.
Yeah. Yes, ma. Yes, ma. That is also part of.
I refer in book, ma'am. That's why I asking.
Yes. This is also part of your network layer protocol only. We have so many protocols that helps in the network layer to efficiently do all these functions, like internetworking, addressing, routing, packetization, fragmentation. What is this fragmentation? Sometimes you may want to, or instead of sending a very long packet, it will be very convenient if they are divided into smaller units and they are transmitted, and that is also taken care by this network layer. Then so many terminologies you will have to come across in this unit. Then multicasting. What is this multicasting? So if I say I'm just I have a message, like I have a text message, but I want to transfer this message not to one single address, but I want it to be transmitted to so many addresses. So that is the said to be called as multicasting. So instead of one single user, I will have more than one user available. Yes, Vivek, you are right. So that process is also taken care efficiently by this network layer. So hope I have given you a brief idea of the network layer and the functionality that is provided by this network layer. Now, as such, we will move on to the exact our syllabus. So as per the syllabus, you can able to see our entire syllabus is divided into three different parts. One is the devices that is involved in doing all this process. So we have all these devices taking part in this process of internetworking as well as doing all the other things. So in aiding this network layer to do all this function, we have several networking devices. So we have repeaters, switches, bridges, routers, and gateways. We'll see each of them now. So today we will be dealing with this. Then we have the two different algorithms, even though you have so many different algorithms, but as such in your syllabus, as it is given only two different algorithms, these two are the most popular among the available routing algorithms. So those two algorithms we will discuss in detail. So that is distance vector routing and link state routing algorithms. Then addressing subnetting, and we will deal that. Then we have all these are the different protocols, IPv version 4, 6, ARP, RARP, all these. So these entire thing is are all names of different protocols which will be helping in the network layer to efficiently do all these functions. So as such, you have these four topics as part of your unit 3. So this is how we are going to proceed. So shall I move on to the next part? So do you have any doubt in all this? Anyway, we will be dealing all these things in detail in the later forthcoming classes. Just a second, I will close all other windows so that it is not going to hide you. Okay. So now look into the connecting devices and the correlation between the different devices used and the layer of our network. So we see on the bottom, we have the physical layer. So now just below the bottom layer, we have the hubs. Hubs are nothing but just the connecting point. And so the physical, just below the physical layer, the device connecting device used is the hub, which you call it as the physical hub. And repeaters, we use repeaters for the physical layer. And then for the data link layer, bridges are going to be used. And in the network layer, it is the router which is going to take part for connecting the different units. And gateway is meant for all other layers, especially with the transport layer and the application layer. So 1, 2, 3, 4, 5, these 5 connecting devices we are going to look into this in today's class. Now moving on to the connecting devices. So as such, we can broadly classify your connecting device as under two categories, one meant for networking and another one for internetworking. Understand the meaning? Network. What is actually a network? So I have a LAN is a network. You see, if you take a small room, in that small room, if you have some 4 systems connected or 4 devices connected, how to connect them efficiently? That is taken care by the 2 connecting device. One is the repeater, and another one is the bridge. Okay, and then so we have the 2 different networks. So we suppose I have I can say we have 2 different networks, and if they are going to be connected together, then the most we use the connecting device, which are the routers and the gateways. Okay, so I can broadly say that this networking will, or the devices under networking will be capable of connecting devices which are, or I can say with the which is capable of connecting these 2 devices will have some restrictions. In the sense, I can say that we can able to just a second, ma. Just a second. Some sound is coming. I'm just removing the time. Just a second. Okay. So we were dealing with this network layer, devices meant for the network layer. Go back. So, yes, ma, can we proceed? Yeah. So what is the use of this interconnecting devices? The very purpose of this interconnecting device is that it is possible to connect different nodes together using the network. That is, it is possible to connect a lot of nodes in the network. Then it is possible to, suppose you say you have land, you have different Ethernet cable, right? At most, each and every Ethernet cable will have a certain restriction in the length. But still, if your LAN, if you want to, if your hall, if your room, which you are planning to connect using Ethernet is said to be of longer, I mean, they are apart by a longer distance, then you can make use of these devices so that you can extend your net, the distance with which you extend the network can be increased. Then you can able to localize the traffic on your network using this connecting device. Then it is also possible to merge the different existing networks together. Especially, I can say the routers and the gateways are capable of connecting devices. I mean, the network which differ in the protocol also. Okay, and then we can able to isolate the network problem so that it is possible to diagnose them more easily. And as you know, internetworking is the one in which we connect the different networks together. Okay, that is very much required because we don't know only inside the particular network alone. We need not have the source and destination. It can also be available in a different network. So it is very much required to connect these together, and that is to be called as internetworking. And the devices that are meant for interconnecting the different network are the routers and the gateway. So we know we have the entire layer, 7-layer or 5-layer architecture, in which each of the layer we can able to see the different connecting devices. So for the layer just below the physical layer, we use the hubs, whereas for the physical layer we use repeaters, and then for the layer above that is for physical and data link layer, we have the bridges, and then the layer for the next layer, physical data link and network layer, we use routers. And the gateway is said to be the one which is applicable for all 5 layers. Now moving on to the very first device, the simplest among all, we have the hub. Just hub is just a connector. We call it as a node. It means we have different devices. So we can able to see here, we have 1, 2, 3, 1, 2, 1, 2, 4, 5, 125, 5, 6, 7, 8 like that. some 6 systems available, and they are connected together by a star topology. Just for example, some topology is being followed, and you assume that it's a LAN and it's a connected LAN. It is wired LAN, it's an Ethernet. Okay, so at one point of time, you can able to see a point at which will be the junction of the signals coming from different stations, and that point you call it as the hub. Okay, so that is simply said to be a connector. Okay, so with this hub, what actually happens is this hub is a very simplest connecting device. So what happens? It is not possible for this hub to differentiate the source and the destination. So just whichever signal, say if a signal is coming from system number 123, the address source is 123, then after getting it, hub just transfers it to all other things, all other connecting devices to it. So as a result, say 123 and 124 are transmitting the signals at the same time, then what will happen is there is possibility for collision. So when a collision occurs, then it is said to be a problem. So that is the feature of this hub. It's mainly meant for the layer before that is below the physical layer, which will handle the raw signals. Okay. So what is actually the solution for resolving this issue? So what is the internetworking device that operates in the physical layer alone? So that device which operates in the physical layer alone, just a second now. The device that operates in the physical layer alone is said to be called as the repeater. So what actually happens in the hub? It means I can say that hub is a very elemental connecting device. It just connects two ends or group of ends. It's just a meeting point. That's it. But you just imagine if there is a provision. Say if I say an Ethernet cable, how long you think will be an Ethernet cable useful to connect two devices? At most 500 meters, 600 meters, like that. Only it has a restriction. Suppose if your room is a very big one and you need to connect two devices inside the room using the Ethernet. So how can that problem be resolved? That can be resolved by using a repeater. Okay. So what is actually a repeater? And we will see to that. So a repeater is said to be a connecting device. It is said to be operating only in the physical layer. What is actually is done by this physical layer, by this connect repeater? We just imagine, see, I'm speaking to you. Okay, just imagine you are in class, and I want to convey some message. Okay, instead of conveying the message from from me to you directly, if there is some mediator in between, you just imagine you and me are apart by a longer distance. So what happens when I speak to you? As such, if I speak to you and if you are at a longer distance, there is every possibility of my voice being heard by you in a very feeble way, isn't it? So to avoid this problem, what I can do, I can just appoint a person in between so that what I speak, if that is replicated, if he can able to repeat what I speak to you clearly, then there is no chance of you hearing my voice. There is no chance you can able to hear my voice more clearly as if I am speaking. So that is the work done by this repeater also. What actually is done in the repeater? It is going to receive the signal, and before the signal is going to become very weak or is going to get corrupted, it is just repeat what it is going to get to the next site. Okay. So that is the work that is done by a repeater. It's mainly meant for actually increasing the length of the Ethernet. So wherever you want to connect or you want to have a longer length connection, then you can divide that longer length wire into smaller unit, which you call it as a segment. And between the two segments, you can fix a repeater. Some may have a doubt whether the repeater is an amplifier. Definitely not. Repeater is not an amplifier. So I will just see here. So we can, here is an example given. So this is one sender side and this is a receiver side. And they are connected. We try to connect them using the Ethernet cable, 10/5 Ethernet cable. So at most, this is only capable of connecting, maximum length is only 500 meters. But if I say the distance between this sending end and the receiving end is something like 900 meters. So I cannot connect them together using this wire, but still what I can do is, if this is of this much length, I can just divide this into smaller units, that is called a segment. So in between the segment 1 and segment 2, this is segment 1, this is segment 2, I can fix a repeater. So what this repeater will be doing, it will get the signal and it just repeat what it has received to the next segment. From segment 1, what it is receiving, it will just repeat to the other side. It is not going to amplify, it is just going to repeat what it is going to get. Okay, it's also it's a two-port node. What is meant by two-port node? So in one side, if I say input, the other side will be the output. So this is, at a time you can able to have one input and one output. This is the work, or this is the called as a two-port network. Okay, it's said to be a device which operates in the physical layer alone, mainly meant for removing the disadvantage of the Ethernet link. We'll move on to the next slide. So just you look at this. You look at this slide. So here there is one frame, this is a second frame, and we are using a repeater here. What is happening with the repeater? It just repeats the two frames and we get the regenerated signal. Okay, what is happening with an amplifier? We are getting the improved version, the amplitude, the signal strength is improved in an amplifier. One other example. See here, we have the repeater, the input, that is port 1 of the repeater is receiving the message 10000010. The work of the repeater is just to repeat what it is going to get. It's not going to amplify, it's just going to repeat what it is getting, provided you have to fix equal, that is repeaters at equal, or I can say at regular intervals, such a way that there is not even single possibility for any kind of corruption or addition of noise to the original signal. Okay. So this is the function that is done by a repeater when the data is transferred from right to left or from left to right. So this is the place where this repeater is fixed in the physical layer. What is the disadvantage? What is the problem that is associated with this repeater? So what actually this repeater is doing, it's just repeating. There is no any kind of filter operation available, provision available with this repeater. So data which you say as a bit, when it arrives at one port of a repeater, it sends out on all ports. So, and I can say that this repeater does not have any kind of filtering mechanism. It means, suppose I have, see, if you look at this. If you look at this diagram, suppose A wants to send a message to D. What this repeater will be doing is, it is not possible for the repeater to identify the address of D, but just it will repeat what it is getting to its port, so that the message which has to, which is supposed to be received by D will also be received by C, will also be received by C. So that is the main problem associated with the repeater. So it does not have a provision to do or identify the address, or I can say there is no filter provision associated with this repeater. So the ultimate result is, we find that at times when more data, when the segments of a network are as a result of the repeaters, when they try to send to all the other connecting unit to in the network, there is every possibility of collision. So that has to be avoided or should be overcome, which is wherein you need to provide with another device which is capable of doing this process of filtering. Okay, so and to avoid we use so to avoid this effect of filtering or unfiltered signal, as well as to reduce the number of collision, we go for the next internetworking device, that is a bridge. So what is all about this bridge? So this bridge is given a provision for filtering. It means it is going to eliminate the unnecessary traffic, and even it is going to reduce the chance of collision that is occurring in a network. How this is going to do that? We'll see to that now. So what about the features of this bridge? So bridge are also connecting device. Where do they operate? We use these bridges for both, that is in the physical layer as well as in the data link layer. What actually these bridges are going to do? They can divide a large network into smaller segments, and actually they are given a provision for filtering, so that uh, it means that they are given a table in which they can refer to the table, and they can able to transfer the packets from the source to the destination alone, not to not like the repeaters where they will be transferring to all other devices connected in the network. Okay, so as a result of this, there is there is a possibility of avoiding the collision, and there is also possibility of uh, security through this partitioning of traffic. So this is how actually it
What type of
works.
traffic? What type of traffic does it overtake the bridge?
Padma?
What type of traffic is dealt with by bridges?
Traffic in the sense, I say that later on we will be seeing that bridges will have a provision, that is will have a table in which they will refer from the frame that it is receiving. It will find out the destination and the source. Okay, and it will transfer the data, that is the frame, to only the destination. So when the frames are sent only to the destination, then the traffic will be more, it will have more control on the traffic. Okay, so that is what is illustrated, is what I meant as traffic. Okay.
Okay.
So we see here segments from device A through bridge is connected to another device. Look at this. This is a bridge. So we have on the top, we have LAN 1. On the bottom, we have another LAN. And to LAN 1, we have 4 devices connected. To LAN 2, we have 4 other devices connected. And they are connected together by use of a bridge. So you see here how a bridge is going to work. So what happens here is the bridge will have a table in which it will contain the it will have 2 fields. One is the address of each and every device. The next field is the it will be the LAN to which, or the port to which the devices are connected. So again, the bridge is also a 2-port network. It means it will have one port. It will have only 2 ports. So to one port, as you see here, just you can say this is one LAN, this is another LAN, and suppose data has to be transferred from device A to device D, and this bridge, what it will do is from the table, it will come to know that A has to be, that is the source and the destination are available in the LAN, the same LAN, so it will not forward the frame to the next LAN. Whereas here, what it will do is from the table, it will come to know that it has to transfer the packet from this LAN to the next LAN through the bridge. So it will forward the frame. that is from port 1 to port 2, because port 2 will have the connection for the LAN 2 to which the device D is connected. So they operate in the data link layer. So in the data link layer, what is actually available in the data link layer? So you know, data link layer, in data link layer, each and every device is provided with a MAC address. Okay. So you look at this I think can give you a better idea. The same thing is illustrated here by the number. So we have the LAN 1 on the left side and we have another LAN 2 on the right hand side. And we each and every device is have their own address. So this is the bridge table. So the bridge table will have two fields. One is the address field, which corresponds to the address of MAC address of each and every device present in the network. And the port, this port means, as I told you, the bridge is a two-port network, two-port device. So to which port these devices are connected, that is port 1. So I can see here 71 2B13, like 41 is for this device, 42 also belongs to LAN 1, whereas 12 and 13 belongs to LAN 2. Suppose a data has to be transferred from 41 to 13, it will first this port 1, after receiving the data, I mean from after receiving the frame, it will come to know that the source is available in port 1 and the destination address is available in the port 2. So it will transfer the frame from port 1 to port 2. Means if the data has to be transferred from address 41 to address 13. Suppose if the data has to be transferred is from 41 to 42, then the bridge will, from the bridge table, this device will decide that it need not transfer the packet that is framed through the bridge, and it will just, because it belongs to the same LAN. So this is how it is going to work. So how actually the bridge, that is the table, is going to be formed? How the table is?
Bridges with the messages sent, will it be exposed to other systems of the same thing?
I'm not getting ma. Come again.
So when you go to previous diagram,
Yes, just a second. Yeah, tell me. Sorry.
if here message needs to be sent from 41 to 30, then the message will travel from port 1 to port 2.
Yeah,
And
through
while
the bridge.
traveling, is it possible that the same message is also delivered to a system 42 and system 2?
No, no, no. That is the feature. It will not. It will not. That is the problem with the repeater. Repeater has no provision for identifying the destination. So it will flood. It will flood the network with all the data that is, with all the frame that it receives. Suppose instead of bridge, if you use a repeater there, repeater, what it will do is it will take the data from the source, as you told, it's from device 1 with address 41, and it will convey to all the devices connected in the network. It is to all the devices available in LAN 2. So that is the process done by, or that is what is done in a repeater. Repeater, there is no provision for identifying the the destination address. So as such, what it is receiving, it will send it to the, it means it will be sent to all the devices, whether it is the destination device or not, just it will flood the network. Understand?
Okay.
So shall we move on?
Okay.
Okay. So now we'll look at this network. We see here that we have how many LANs connected? We have 3 LANs. So bridges can be used to connect any number of network. So in this, we have 3 different LANs. So LAN 1, LAN 2, and LAN 3. So we'll see how this bridge table is formed now. So actually, these bridges are given a provision, that is, they have an intelligence from the packet, that is from the frame that it receives to the port 1, and how it actually transfers the packet to the other port. From that, it will come to know the presence of a particular device in the corresponding LAN. Okay, so initially the bridge table will be completely empty. So from this, we will start how this bridge is going to build the table. Okay, so as such, you can able to see here in this diagram, we have LAN 1, LAN 2, and LAN 3. LAN 1 is going to have two devices A, B. LAN 2 is going to have two devices C, D, and LAN 3 with the two devices E and F. So let us take initially the table is empty. So a frame is coming from LAN 1. So to the port 1. So bridge on finding that is the frame, it will come to know that the source, that is the device with address A is for LAN 1. From the frame that it is receiving, it will come to know that it is the device A is associated with LAN 1. So it will update the table as address A with port 1. Okay, as is this connected to port 1. Now, this is an example where A is sending a frame to D. Now, as such, the bridge does not have any other information. It does not have any other information about D, isn't it? D's destination, in which LAN it is available, it is not known to the bridge as such. So what it will do is it will send the frame to all the LANs. Okay, it will send the frame to it will flood the network. Okay, so and after that, so now A with port 1, address A is associated with port 1 is learned, so that is updated in the bridge. Next time, and it will, suppose if E is sending a frame to A, then the frame from E will be received by this bridge, and from that frame, it will come to know that E is available in port 3. So it will update the table as E with port 3. Then already it has found, already from the previous data transfer, it has learned that A is associated with LAN 1. So it will send the frame from bridge, that is from port 3 to port 1 to the destination, that is the device A, that is to the address A. And then now during the next time, after B sends a frame to C. Now again, B it is going to send a frame to C. It will again, where is B located? B is located with the LAN 1. So when it gets the information about that is from the frame, it will come to know that B is associated with LAN 1 or with port 1. So it will update the table. And then it will send, as it does not know the information regarding the destination, it will flood the network to all the devices associated with it, and likewise the table gets updated. So at one point of time, it gets the information about all the devices and their address, to which port they are associated with. That information will be received by the bridge, and the bridge constantly updates itself. It has a provision, it has some artificial intelligence, or I can say it has, an algorithm which is being followed in this device, so that it is possible for this bridges to update itself based on the packets that it is receiving, that is frames that it is receiving, and based on that, and as well as the frame that it is sending. Okay. So this is how a bridge table is updated by this bridges. Now, we'll see the problems associated with the bridge. The main problem that occurs with the bridge is the loop problem. What is this loop problem all about? It's very important problem. Loop problem is a very important problem, and we use spanning tree algorithm to remove this loop problem. Any idea about this loop problem? What is a loop? What is a loop? So I have You know about graph theory, ma? Any idea? So let us assume that we have three devices and they are connected together by these line or by this is one network in which we have three devices and they are connected by three different I mean they are connected together. So this there is a closed path. That is, I can, if I start from device A, I can travel to B, C, and then I'm coming back to A. So this is said to be called as one complete, a closed path, which you call it as a loop. So what actually happens is the loop problem is said to be an undesirable problem, which is always said to be avoided. It means somehow we should not prevent the packet that is sent from A. Suppose a frame is sent from A, a data is sent from A, then the same data loop is a sequence of instruction that is it's you are, I'm not talking from the point of the instruction or from the point of program. This definition what you are saying, Srikanth, is relating to an
Network,
instruction.
ma'am. About network.
No, what definition you have given me is relating to that is the
Computer network.
is it is relating to this is a Google answer, ma?
No.
Then
Seen book.
so loop, as you told, it's a sequence of instructions that gets completely repeated based on some condition. That is the general meaning of the word loop. But from the context of bridges, I'm going to tell you about the problem associated with this loop, which you call it as associated with the computer network, which you call it as the loop problem. So from the context of a network connected using bridges, a loop is said to be the one where you have a closed path, which means it is said to be ending on itself. Okay, so somehow we have to avoid that. So we use different algorithms, and the most famous algorithm is the spanning tree algorithm. Let's see to that. So we have, say, if the aim of any network, what is the aim of any network? What should be the aim of any network? Connect all the devices in an efficient way, isn't it? So I have device A, device B, device C. So this is in an efficient way implies it could be efficient in terms of the number of segments you use. It could be number of anything it could be. So it based on the cost function. So here, this is one way of connecting the three devices. What is the other way of connecting the three devices? Just I can have A, I can have B here, C here. This is another way of connecting. Anyway, we have connected all three devices, isn't it? And then what is the other way of connecting? So A, B, C, A, B, C. Then this is B. So A, B, C. What else could be the way of connecting them together? This is C. You can open this page. Okay. So these are the three different ways you can connect the three devices in an efficient way. So nowhere we can able to see here that all the devices are connected, but still they are not having a closed path. It means what happens actually here is when there is a loop formed, at the data that is sent from device A after a delay, or I can say it is going to come back to this same point A again, which is said to be a problem as far as bridges are concerned, which is said to be called as loop problem. Now with the real, what is the time? Time up, right? So, okay, with this example, next class we will explain you this loop problem in bridges, and I will also tell you about the spanning tree algorithm, which is very important and is said to be very interesting algorithm. based on this is a graph representation of the network. Based on that, I will tell you. Okay, with this I'm stopping. So with the we will discuss the spanning tree algorithm to eliminate the disadvantage of this loop problem in bridges. Then we will move on to the disadvantage of bridges, how that is overcome in a router. We'll move on to routers and then gateway. With that, this topic will be over. So I'm stopping the class with this. So you have any doubt up to now, you can ask me.